Hey everyone, welcome back to yet another video in our JMeter series. Today we are covering how to use JMeter timers to properly model workload using two simple HTTP requests, one for google.com and bing.com, and they are running inside a stepping thread group. So if you hit these sites back to back with zero delay, let's see what happens. Then you are not doing performance testing, you are spamming the requests. So in real world, users don't go this fast. Users pause between actions. They sip a coffee or take a break, they come back, switch the tabs, and accordingly you need to simulate real world delays and pauses, and also the system throughput must be paced. So let's look at how think time and pacing apply to our Google and Bing script. These are the two HTTP requests, so I just use this as an example. And first let's look at think time. Think time, as the word says, is the gap between individual requests. So when a virtual user hits google.com, so when the test starts, we are simulating a user going to google.com. The user pauses for, let's say, 3 seconds to read the results, and then navigates to bing.com. And that 3-second gap is your think time. And the pacing, what about pacing? Pacing is the gap between full test iteration, the complete iteration. The delay between the start to finish is one iteration. After doing the one iteration, after completing both Google and Bing request, pacing adds a delay before that same thread starts the loop over again. So the think time models human behavior, while pacing controls your target transactions per second, which is TPS. So if you skip delays, you create queue saturation and thread synchronization spikes. Right when a server slows down, your threads slows down too, causing JMeter to send fewer requests and masking real bottlenecks. So now let's configure our timers in JMeter using these two HTTP samplers. So first, to add realistic think time between google.com request and bing.com request, we can add a uniform random timer as a child element right under this bing.com request. To do that, right click on the HTTP request and then click add, and then go to timers and then select the uniform random timer. There are a lot of timers, but let's look at this one. So this timer is now being added as a child element right under the Bing sampler, the HTTP sampler. So remember, timers in JMeter execute before the samplers they belong to. That is, in other words, this timer first executes before this step is executed, and then it goes to the next step. So in each step, if there is a child timer, that is executed first before the actual sampler is executed. The sampler to which they belong is executed. So here is the formula for the total delay generated by a uniform random timer. So if you set the constant delay in the timer, if you set a constant delay of 2 seconds, that is 2000 milliseconds, which is the constant delay offset, and a random delay maximum of, let's say, 1 second, which is 1000 milliseconds. So now what will happen is JMeter will pause randomly between 2 seconds and 3 seconds, 2 and 3 seconds, right after the Google HTTP request, right after the Bing request finishes, and right before Bing fires. Or in the other way, this timer kicks off right after the Google finishes. Right after the Google finishes, it goes to the next loop. So let's say here is the end of the end of the test. There are no more steps. So the final HTTP request goes to google.com and then it comes back for the next iteration. So before starting this iteration, as I said before, the actual HTTP sampler is not executed first. Any child timer associated with that HTTP request is first executed. So JMeter will randomly pause between 2 and 3 seconds after the end. That is, so it pauses here first and then sends the get request. Here you can see, and it goes to the bing.com. Now let's control the overall throughput across our stepping thread group. Now this timer is a child of a HTTP sampler, so it affects only that sampler. But for the whole test, it iterates again and again. So it sends 2 requests. So when I run the test, you can see that it goes to Bing, Google, and since we added a timer here, it's not that fast. This uniform timer introduces a pause, as we can see here. So it iterates. So the next what we are going to control is the overall throughput. That is the overall how fast the entire test runs, the iteration. The performance test keeps iterating here. So at the end of each loop, we can control the overall throughput, the traffic throughput across our stepping thread group using the throughput timers. So there are many types of timers here, and you can see here when you right click and go to timer, there are 2 types: precise throughput timer and constant throughput timer. So we are going to look at precise throughput timer. So we can move it anywhere here. So you can place it anywhere here, whether at the top or at the bottom. It's going to affect the whole iteration. So it's going to maintain that, control that, the throughput. So if you let's look at the configuration. So if your target throughput is 60 requests per minute. So this is the per minute period. So if you have your target throughput to be 60, so it will control the traffic so that the rate of traffic hitting your server is only 60 requests per minute across both Google and Bing.com requests, or the overall load is 60 requests per minute. So imagine these are same domain. Here, for example, I have given different domains, but this can be Bing/images, or this can be Bing/. It's going to be the same domain. So basically, it is controlling how much traffic is going to be arriving to you at your server. So 60 requests per minute across both these HTTP sampler requests. And you can also set the throughput, target throughput, and the target throughput period. That is, let's say, put 60 seconds. So for this period of 60 seconds, it's going to maintain 60 requests per second. So that is the target throughput of 60 and the throughput period to 60 seconds. There is another timer called the constant throughput timer. So let's look at the difference between these two. The precise throughput timer uses a Poisson distribution. This actually what it does is it distributes your let's say here the Google and Bing requests naturally without locking threads into artificial timing bursts as your stepping group ramps up. So you got the point there. So that's also, you can see the settings here. There are not much settings. All you need to say is how much target requests you want per minute, and which is going to be applied to this thread only or all active threads, and so on. So pretty much minimum control there, minimum configuration. But here it uses the Poisson distribution, so it asks for the throughput period. So we have to give the throughput period and the target throughput, and you can also specify more advanced configuration like the number of threads and the delay between the threads in the batch, and you can read more about that in the documentation. But for this quick example, all you need to know is these two timers are different in that way. So here is the formula that you can use to calculate the target loop time, and secondly you can also calculate your required pacing delay. And for example, if your stepping thread group has reached 10 threads, let's say 10 active threads, and your goal is 2 transactions per second. So even though you have 10 users, you want to control your number of transactions, that is the number of traffic hitting your server, to be only 2 requests per second. Then the target loop time can be calculated by the number of users, which is 10, divided by the TPS, which is 5. So you get the target loop time to be 5 seconds. So, and also if the combined response time for the Google and Bing plus your think time you want to be, let's say, 3 seconds, your pacing delay calculation is that 5 seconds minus the 3, because that the think time you have to remove from the, because the think time does nothing, so you have to subtract from the 5 seconds. So the pacing delay is 2 seconds. So adding a 2-second pacing delay at the end of the loop keeps your throughput steady at exactly 2 transactions per second. So that's why we have to subtract the 3 second think time. So you get exactly the 2 TPS, the transactions per second, regardless of server response time variations. So to wrap up, use uniform random timer here, this one, for think time between requests like Google and Bing, or any steps in between. You want a uniform random timer. Use the precise throughput timer for all to control for overall throughput goals, and calculate the pacing to keep your TPS steady. So if this video helped you understand JMeter timers, hit the like button and leave a comment with your question below. So in the next video we will cover the topic on the CSV dataset config, so your virtual users can search for dynamic keywords on Google and Bing instead of hard-coded items. So subscribe to the channel so you do not miss it, and I will see you in the next video.